In my talk, I'm going to give a brief introduction to the concept of individualized disease risk monitoring and why it's important. I'm also going to talk a bit more about DNA methylation that we've already heard quite a lot about, but how it fits into that piece of the puzzle. And I'm also going to introduce the lifestyle cohort, which is work in progress as part of the HEAP program. So I'd like to start my talk today with this simple example. All of you will have seen this one way or the other. So in cardiovascular disease, we have one key risk factor, which is high blood pressure. We know about this risk factor and we can monitor it using a simple and non-invasive tool, the blood pressure monitor. So people can do this at the doctor's office or even at home. And because we know about this risk factor and we can measure it, we can do something against it. For example, taking medication that reduces our blood pressure or consuming less salt. And a key aspect of this is that we can then monitor whether this action has been effective. So actually this should be more or less like a little, no, this doesn't work. So it could almost be a little loop that we say, okay, we have the risk factor and we can monitor it. We're working in cancers, so Professor Wichwenter has already given an overview into the cancers that we're interested in. And for one, there's many risk factors. Some of them we might not even know at this point. That's not what I'm focusing on at the moment. However, the key barrier we're facing at the moment is that we don't really have a tool to really estimate the individual risk. So for example, we know that smoking is causing cancer. However, the majority, so some smokers will develop cancer, but not all of them, and also some people that don't smoke might develop lung cancer. So there's really this kind of individual component, so we can't really measure our own risk. This also means that whatever preventive action we take, we don't really know whether it's been effective for you as a person. So we really need a tool to monitor the individual risk. Now, genetic testing has already helped us a little bit with this. So for example, we know that women with a mutation in the BRCA gene have an elevated risk for breast cancer. However, it's not really considering the other aspects. So we're not here to talk about genetics, we're here to talk about the exposome. So how do individual components link with the exposome? So I've already, Professor Wichwenter has already talked about this a little bit. So as we go through life, there's various factors that imprint on our epigenome. So we have hormones, smoking, diet, toxins, all of these things can really converge and they leave a signature on the DNA. So I'm going to the next slide. So as you can see here, this is really simplified, so please don't quote me on this, but basically what we're seeing that as we go through life, smoking will, for example, leave one signature, and then we have diets, which might leave another, cancel out some of the effects. And obviously as we age, our epigenome changes. And what is really interesting is that DNA methylation also influences how our cells behave. So cancer cells will have a different epigenome. And we can measure this signature, but also in cells that aren't yet cancerous. As I've mentioned, it's more dynamic than genetics because it includes both genetic factors, but also the environment. But what is another advantage is that it's not as volatile as, for example, gene expression or metabolomics, which provide more of a snapshot. So this is really kind of an integrative view of what's happening or what's happened to an individual. So we have in the past defined these epigenetic risk signatures, which are called women's cancer risk indices, and also markers of cellular aging, which Professor Wichwenter has just presented. I'm not going to talk about this in too much detail. However, I wanted to briefly mention this to you. So using cervical samples, we were able to look at the epigenome and we're able to detect and possibly predict breast and ovarian cancers with quite a high sensitivity and specificity. So these are both published, so if you're interested, please have a look. However, one question that's still open is whether we can really use these epigenetic signatures to measure dynamic changes, for example, following lifestyle changes, because that's the ultimate goal for really to enable this individualized prediction. So the idea, again, a little bit simplified, is that we have, for example, a healthy individual that has an elevated risk, for example, because they're a heavy smoker. And then we ask them to do a preventive action, so stopping smoking, and then monitor the epigenetic changes that follow this intervention, and the ultimate goal being to provide individual cancer risk monitoring. So as part of this study, we've included over 150 women, so we're focusing on women's cancers, aged 30 to 60 that either have an elevated BMI or are heavy smokers. And I'm going to give you a brief overview of kind of the study flow. Sorry. So I'm just going to bring up the entire slide. Okay, great. So this is kind of the study overview. It is quite a complex task. Any of you who have done interventive studies or following up patients know that this is quite a big task. So we have about over 50 collaborators, a team of several dietitians at this point. So we have two key interventions. Those are highlighted at the top. So we're looking at intermittent fasting or smoking cessation. Women come to us at baseline, so that is before they start with the intervention, and then we do a variety of things. So first of all, we're interested in collecting multiple samples. Professor Wichwenter has already explained that the type of sample actually is quite important for epigenetics, so we're collecting several different types of samples for different analyses. Women also get a fitness tracker, so we're looking at resting heart rate and other factors that are associated with sleep or VO2 max. And women also receive a comprehensive health check, so looking at vascular health, kind of ergonometry, lung health, and also optional skin biopsy. Interestingly, the majority of our participants have volunteered to do so, so it really shows that there is a high drive to participate in research. And we're also obviously asking about the kind of medical, epidemiological history, psychological health, and quality of life. So this is kind of just to get a baseline, and then we ask participants to start the intervention. They will receive one-to-one coaching throughout the entire 6 months, which also helps us to get quite detailed compliance information, because we can ask them basically every week, how many days have you managed to do the intermittent fasting, or how many days have you been able not to smoke. They will come in month 2, month 4, and month 6 for sample collection only. And at month 6, they will also additionally receive the tests that they received at baseline. And so this is kind of the main study time, but we're also asking them if they want to come back after a year and 18 months, just to see what happens after the intervention, or kind of if we're not asking them to continue doing it, what would happen to the epigenome. So this is still an ongoing study, so unfortunately I won't actually have any data to show yet. However, I wanted to show some data on kind of the feasibility, because not only is such a study a huge project for the people running it, but also the participants, because you have to imagine they have to come in every 2 months. It's quite an invasive, so to say, thing for their personal life. This slide is actually, or the graph is a couple of months old, so we're now nearly done with the study. However, in the dark orange, you can see the number of dropouts, and especially for the intermittent fasting groups, it's quite low, so it's actually below what we would expect for some sort of intervention trials. Interestingly, for the smokers, it was higher than expected, so it does highlight that perhaps giving up smoking is not as easy as we had assumed. But anyway, so we had relatively low dropout rates, and we're almost done with the study. So hopefully by the end of July is our last month 6 visitation, and then we'll get to analyze the study data, focusing, of course, on epigenetics, but we're also looking at the microbiome, obviously, because diet changes the microbiome. We're going to do some single cell sequencing, so there will be lots of interesting data to come from that, and hopefully if we have a meeting next year I can share a bit more of that. So to go back to the original slide that I showed, I think we all agree that prevention is better than treating a disease once it's been established. I hope with my talk I could give you a brief insight into why epigenetics might be kind of a key aspect in helping to estimate the risk for cancers. So we have these signatures. They still need to be further validated and tested in the clinic, but we have a kind of very good indication that this might work. What is still work in progress is whether we can really use it to monitor effectiveness of interventions dynamically. We believe that the HEAP lifestyle cohort is quite a unique resource, and we hope it's going to enable lots of interesting discoveries. So I'd like to thank our funders, of course. So the majority of this funding is coming from within HEAP. Also, some of it is coming from the Land Tirol, which is our region in Austria. And of course, none of this would have been possible without our team and leadership and collaborators. So thank you very much. If you have any comments, ideas, would like to collaborate, or would like to complain, please reach out. Thank you.